This screencast covers the basics of comets. Okay, first of all, what is a comet? Well, a comet is basically sometimes referred to as a dirty snowball. It is primarily composed of water ice, ammonia, and various types of carbon compounds, giving it a dark color. Comets are ultimately the leftover debris from the formation of the solar system. They originate in two regions of the outer solar system called the Kuiper Belt and the Oort cloud. It will be covered in the context here of this screencast. Okay, here is the same object from the previous slide. It's named after two Russian astronomers who discovered it. And then as the object begins to approach the sun, then basically all of the ices associated with the comet's nucleus, well, they then begin to sublimate. They then begin to melt off. Some of that material interacts with the solar wind, and that ionizes some of it. This then produces one of the tails of a comet that is called an ion tail, and it points directly away from the sun. This particular comet, by the way, was studied quite extensively by a European spacecraft in the previous decade, referred to as Rosetta. Okay, here's the basic structure of a comet as it's swinging around the sun. You have, first of all, the comet nucleus buried deep within this halo of sublimating gases called the coma. The nucleus itself is usually on the order of maybe a few kilometers wide or so. And then you have two tails. You have, first of all, the ion tail, like so, which points directly away from the sun, and it could be on the order of 10 to the 8 kilometers long. And then some of the gases and ices and so on and so forth that have been sublimated off the nucleus of the comet, well, that then results in a dust tail, like so, and then this material here basically ends up in orbit around the sun. Okay, as I mentioned a few minutes ago, basically comets originate in two regions in the outer solar system, what is referred to as the Kuiper Belt and the Oort cloud. This is basically the leftover remnants, if you will, from the formation of the solar system. The Kuiper Belt is a disk of material that extends outwards from about the orbit of Neptune to a distance of about 50 AU from the sun. It is the source of what are called short period comets. Short period comets typically have orbital periods on the order of a couple of decades, and all of the elliptical orbits associated with such comets are basically aligned with the ecliptic, the plane of the planets, for example, as they orbit the sun. What ultimately causes one of these objects to fall into the inner portion of the solar system and become a comet? Well, that depends upon the gravitational interactions that occur between the objects within the Kuiper Belt. Pluto, by the way, is considered to be one of the larger Kuiper Belt objects. Okay, and then much further away from the sun, in a spherical halo of debris stretching out to a distance of about a half a light year or so away from the sun, is what is referred to as the Oort cloud. The Oort cloud is the source of the long period comets. Comets that have orbital periods in the neighborhoods of tens of thousands of years. And then all of those comets that do periodically fall in towards the sun, well, they do not come from any preferential direction, like, for example, the elliptical orbits associated with short period comets, which align with the ecliptic. Instead, we see long period comets basically coming from all directions of the sky, and typically the orbital periods associated with these comets is in the neighborhood of thousands, or even in some cases, tens of thousands of years. So this is one of the reasons why we know that the Oort cloud is there, because it's the source of what are called the long period comets. Okay, here's a series of photographs of some rather famous comets over the last couple of decades. Once again, comets are usually named after their discoverers. This right here is Comet Hyakutake, which passed close to the Earth back in 1996. It had a pretty small nucleus, but it was actually a fairly bright comet due to its close proximity. One of the most spectacular comets of the last few decades passed in the inner portion of the solar system in 1997. This is Comet Hale Bopp. It has an orbit on the neighborhood of 50,000 years, so it's a long period comet. It's an Oort cloud object, and the nucleus itself of the comet is quite large. It's on the neighborhood of like 100 kilometers wide or so, something like that. Bright comets, by the way, are usually visible about once per decade. As you can see here in this nice detailed photograph of Comet Hale Bopp, there are two distinct tails. You have right here, first of all, the blue ion tail, which points directly away from the sun, and then the dust tail tailing off to the side, like so. At its brightest, basically, from a dark sky sight, this comet was easily visible to the naked eye, and it stretched across about half the sky. It was absolutely spectacular. It passed by the inner solar system back in 1997. Okay, here's a nice picture of the nucleus of Halley's Comet. This particular photograph was taken by a European spacecraft called Giotto back in 1986. That was the last time that Halley's Comet swung close to the Earth. The actual nucleus itself is about 6 miles wide, and you can see here very nicely the jets of sublimating gases from the nucleus of this comet. Here's another famous comet from the 1960s with an extremely long tail. Once again, it's named after its discoverer or discoverers, like so. This is Comet Hyakutake. Here's another nice comet from the 1970s, Comet West. You can see in this very nicely detailed photograph, very clearly the ion tail, like so, and then the dust tail here off to the side. Here's another famous comet from about 15 years ago or so, 13 years ago, from late 2007. This is called Comet Holmes. It was visible to the naked eye from a dark sky site. It had, however, a small tail because the comet itself was almost pointed straight at the Earth. Also back in 2007, there was another fairly bright comet that was visible, but unfortunately only in the southern hemisphere. This was Comet McNaught. It was not visible from the northern hemisphere. And then just recently, just a few months ago, back in the summer of 2020, Comet Neowise caused a number of headlines to occur around the world with its appearance. However, it wasn't a very bright comet. This photograph here is a little bit misleading in that sense. It was just visible to the naked eye under a dark sky away from light pollution. Once again, this passed by the Earth back in July of 2020. Okay, and then very famously, back in the early 1990s, a comet broke up into 20 different fragments as it passed close to the planet Jupiter. And then just a couple of months later, all of these fragments actually slammed into the planet Jupiter. So these 20 fragments here from this comet called Comet Shoemaker Levy 9, as you can see here in this very nicely detailed Hubble Space Telescope photograph, ultimately each one of these fragments then slammed into Jupiter with the world watching. Okay, here's a nice infrared series of photographs here of one of the cometary fragments slamming into the planet Jupiter. You can see it begin to appear here like so. Ultimately, the fireball that you see right here associated with this comet was larger than the Earth. And then here are a number of the fireballs that you could see like so of the individual cometary fragments slamming into the planet. In visible light, the scars from these cometary impacts on the planet Jupiter actually persisted for weeks. Okay, do comets hit the Earth? Yeah, every now and then they do, quite frankly. Back in the early 20th century, probably a very famous example of a comet hitting the Earth occurred in Siberia in the Tunguska River region back in 1908. What we think happened at that time is that a small comet, exploded about 8 kilometers above the ground, and the energy associated with that explosion was directed downwards, and it basically flattened the Siberian forest, as you can see right here. These are flattened trees. It basically flattened the forest for hundreds of square miles. So there are really no witnesses to what actually happened at that time because it was in a pretty remote area of Siberia. But once again, what occurred is what is referred to sometimes as an airburst. So this small comet exploded maybe 8 kilometers above the surface of the Earth. The energy of the explosion was directed downwards, and it flattened the Siberian forest over hundreds of square miles. Okay, now we mentioned, for example, earlier, the dust tails associated with comets, and then that material ends up orbiting around the sun. Well, every now and then the Earth will pass through that material as it orbits the sun, and when the Earth passes through that material, this then results in meteor showers. In some cases, as the Earth passes through that cometary debris, it may result in thousands of meteors in a very short period of time. The Perseid meteor shower, for example, occurs in August of every year, and that's an occurrence when, for example, the Earth passes through the cometary debris of a specific comet. Every now and then, small comets slam into the sun. This right here is a photograph of one such example. These types of small comets are sometimes referred to as sun grazers. Okay, so that concludes this brief screencast here covering the basics of comets.